Most inventors think a working prototype means they're ready for manufacturing, but they're not. The 3D print worked. The design looked incredible. It felt real. It felt finished. Then the factory quote came back and everything collapsed. Now the part is too weak, the tolerances are off, the snap fit failed, the cost is too high, and the product you thought was ready suddenly needs a redesign. I've seen this happen over and over again for more than 30 years and across more than 2,000 product launches. And here's the brutal truth. 3D printing does not lie to you on purpose. It just does not tell you the whole truth. In the next few minutes, I'm going to show you exactly what 3D printing is hiding and why so many inventors get blindsided at the factory stage and what smart inventors do instead if they actually want a real shot at getting to market. Point 1. The 3D printing confidence trap. Here's the first trap. Inventors treat a working 3D print like proof the product works, proof the design is ready, and proof manufacturing is next. But that is not what it proves. A 3D print proves one thing. It proves the geometry can exist. That's it. It does not prove manufacturability. It does not prove durability. It does not prove production economics. And it definitely does not prove the product will survive at scale. Why? Because 3D printing uses materials like PLA or resin. Those materials do not behave like the real production materials. Even if you're using materials that are similar to ABS, polypropylene, or even glass-filled nylon, they still don't perform the exact same as molded plastics. So when your prototype passes a test, you may be testing the wrong thing with the wrong material in the wrong environment. That is dangerous. Then there is tolerance. In a 3D printed prototype, a skilled technician can hand fit the parts together. They can sand an edge, trim a wall, force a snap fit, make a micro adjustment, or compensate for a gap. That human compensation disappears in production. The factory is not loving hand correcting every part for you. At scale, parts need to fit because the design is right, not because somebody got lucky on the bench. And here's where inventors really get crushed. The snap fit that worked beautifully on a print may fail completely in injection molding. Why? Because molded parts perform slightly different. Production materials flex differently, tooling changes geometry, wall thickness matters, draft matters, and tolerance stack-up matters. What worked at 1 unit often fails at 10,000. So let's get this crystal clear. A 3D print validates geometry. It does not validate manufacturability. It does not validate material performance. And it does not validate production costs. Those are completely different questions. And those are the questions that determine whether your product becomes a business or a very expensive lesson. So what happens when you find that out too late? That is where the real damage starts. Point 2, the real cost of finding out too late. By the time most inventors realize the 3D print gave them false confidence, they are actually committed. Emotionally committed, financially committed, sometimes even legally committed. The design is locked, the patent is filed around it, the prototype has been shown to investors, they have told friends, family, maybe even buyers, this thing is real. And then reality hits. The factory reviews the design, says the wall thickness will not mold correctly. The feature needs a draft angle. The part will warp. The assembly will bind. The tolerance is too tight. This material will fail under load. This part count is too high. This tooling cost is way above budget. Now, what looked like a tweak becomes a rebuild, and rebuilds are brutal because now you're not just changing one thing, you're changing the CAD, the fit, the material, the tooling strategy, the cost model, and sometimes the whole business model. That is where inventors lose momentum. That is where they lose time. That is where they lose capital. That is where they lose belief. And here's the part nobody tells you. The factory usually does not warn you up front. They quote what you send them. If your design is wrong for manufacturing, the quote is wrong too. You do not find out when you're dreaming. You find out when you're committed. That is the most expensive time to learn the truth. Every week you spend emotionally attached to a beautiful 3D print is a week you're not validating what actually matters. Can this thing be built properly at scale? That is the question. Not does it look good, not does it sit on a table nicely, not did the print come out clean. Can it be built profitably at scale? Because if the answer is no, the prototype did not help you. It delayed the truth. If you have a 3D printed prototype right now, stop. Before you take another step toward manufacturing, click the link in the description. We will tell you exactly what your prototype is validating and what it is not before the factory charges you to find out. It takes 2 minutes. It can save you thousands. Point 3, what smart inventors do instead. The inventors who consistently make it to market do not start by falling in love with a 3D print. They start with production grade validation. That means the prototype is made from the actual production material or as close as possible. For example, if the final product needs ABS, Validate real ABS. If it needs aluminum, machine it in aluminum. If it needs real structural performance, test the real structural behavior. Now you're no longer guessing. Now the tolerances are real. The fit is real. The strength is real. The thermal behavior is real. The wear is real. And the assembly reality is real. And when the prototype is built from production grade materials, the factory conversation changes completely. Now they're not quoting a fantasy. They're quoting reality. That number becomes something you can build a business around. That is a massive difference. At Rabbit, we build this into the process from day one. The same senior engineer who evaluates your product is involved in the design, the prototyping, and supporting production. There is no handoff. There is no lost context. There is no junior team guessing what the original intent was. Manufacturing reality gets designed early, not discovered late. And that is the real purpose of a prototype. The goal is not just to see if it works once. The goal is to know with confidence that it will work when it is being built at volume with real materials by people who have never touched your product before. That is the standard. 3D printing answers one question you're asking right now. Production grade prototyping answers the question that actually matters. So here's a shift I want you to make. A 3D print validates geometry. It does not validate manufacturability. The confidence it gives you is real, but the data it gives you is often incomplete. And that is why so many inventors get blindsided. They think the prototype is the finish line. It's not. It's the beginning of the most expensive phase of development. And what that prototype is made from can determine whether that next phase costs you $10,000 or $50,000 or kills the project altogether. Most inventors find this out at the factory. The inventors who build real businesses find it out before they ever get there. That is the difference. The material your prototype is made from is not some small technical detail. It is one of the most important decisions in your entire product development process. Most people treat it like an afterthought. That is exactly why most products never make it to market. If you're sitting with a 3D printed prototype right now, or you're about to build one, click the link in the description before you spend another dollar. We will look at your specific product, tell you exactly what needs to be validated before manufacturing, and give you a clear next step. It's free and it's 30 minutes. And it can be the difference between a product that makes it to market and one that does not. So click on the link now. And if you want to understand what actually happens to your product at 10,000 units, the design decisions that get locked in during your first month of engineering that most inventors never see coming, watch this video next. It's the next thing you need to see.